Welcome everybody to Algebra 2, Unit 10, Section 3, Adding and Subtracting Rational Expressions. So before we get into the new content, let's go back to some warm-ups from Section 1 and Section 2. So from Section 1, identify the following for y equals 3x plus 4 divided by x squared minus 16. The vertical asymptote set the denominator equal to 0. You would end up solving it a few different ways. Either you factor or you add 16 and square root both sides. That's what I would do. And end up saying, hey, x is positive and negative 4. Or two different vertical asymptotes. In behavior asymptotes, we say, okay, well, the degree of the numerator is 1, degree of the denominator is 2. The degree of the numerator is less than that of the denominator, telling us the asymptote is at y equals 0, plus or minus any translation, which there is none. An x-intercept can be found by making y 0. You would then multiply by the denominator. That results in, put it over here, 0 equals 3x plus 4. Subtract 4. Then divide by 3 to get x equals negative 4 over 3, which would give us a point, negative 4 over 3, comma 0, which is the same thing as negative 4, or 1.3 repeating, by the way. Y-intercept to make the x value 0, so it would be y equals 3 times 0 plus 4 over 0 squared minus 16. So that would end up getting you 4 over negative 16, which is negative 1/4. Gives you the ordered pair 0, comma negative 1/4. Next, simplify the following. So we factor the top left and the bottom right. Those are the only two that can factor. Top left factors into x minus 3 and x plus 2. Bottom right, x plus 3 and x plus 2. Once again, those can be in either order. We say hey, diagonally and vertically what can we reduce? X plus 2's can be reduced, and that's it. So at the top, you get x minus 3 and x plus 1, which you can just leave factored. On the bottom, you get 4x cubed times the quantity of x plus 3, which once again, you can leave factored as well. I'm fixing my 4x cubed there. On b, we need to multiply by the reciprocal instead of dividing. First fraction does not change. Second fraction reciprocates. Now we see what we can reduce. 32 and 8 can reduce to 1 and 4, not respectively. X cubed and x to the fourth. X cubed reduces entirely to 1. X to the fourth reduces to x. Y to the ninth reduces with y to the sixth to y to the third and 1. And y to the third reduces with y to 1 and y to the second. So on the top you get 4. On the bottom you get xy squared. Now, moving into the new stuff, adding and subtracting with like denominators. So we've done common denominators before when adding and subtracting, and we need common denominators in order to add and subtract. So then you just add or subtract the numerators. So here, 7 plus 3 is 10, and the denominator stays the same, 4x. Apologies. Then we look to reduce. And you can reduce the top and bottom by 2, and you get 5 over 2x. And you'd be done. Example 2, x minus 6 on both of those. So 2x minus 5 over x plus 6. That's as much as you can do. You can't factor the top and bottom at all, and you can't reduce anything. Adding and subtracting with unlike denominators. So first good step is to factor the denominators, then find the least common denominator, and multiply each fraction to get that common denominator. Then you add or subtract the numerators and simplify. Now, in order to find the least common multiple, aka least common multiple is the same thing as the least common denominator of the denominator. The least common denominator is the same thing as the least common multiple, but specifically just for the denominator. So a way to find it is you factor to simplest form, so factor everything you can, then combine each factor to the highest power it occurs. That'll help you out. And we're going to practice it here on 3a, b, and c of finding the least common multiple of the fractions, or least common multiple in general, which will then help us finding the least common denominator. So between these two, the first one, 4x squared minus 16, we're going to factor that into 4, factor 4 out, then be left with x squared minus 4, and say, wait, that's the difference of two squares. So 4x minus 4 gives me x minus 2 and x plus 2. And the other one, we can factor a 6 out, and we're left with x squared minus 4x plus 4. And we can factor that further into x minus 2 and x minus 2. So as we look here, we say, okay, 4 and 6, those are not common factors, are common multiples, but they do have a common multiple of 12. And there's an x minus 2 and an x minus 2, but there's 2 of them over here, and only 1 over here. So the common multiple would be x minus 2 squared, because you would need 2 of them. And then this has an x plus 2, but this one doesn't. So in order to be a least common multiple, you have to multiply the right one by x plus 2. So this would be the least common multiple. This is the lowest value that these two things can multiply up to. And what we did is we took them individually and said, hey, 4 and 6 can go to the 12. X minus 2 and x minus 2 twice can become x minus 2 squared. And x plus 2 and nothing can become x plus 2. Might be a good idea to try letter B on your own. First part factors in 8 out, and you have x minus 2. Second part, you can factor a 12 out, left with x squared plus x minus 6. And it can factor into 12 parentheses x minus 2, x plus 3. And you say, okay, well, 12 and 8, the least common multiple of those two numbers is 24. X minus 2 and x minus 2, well, least common multiple is x minus 2. And nothing with x plus 3, least common multiple is x plus 3. So our entire least common multiple is 24 times x minus 2 times x plus 3. I encourage you to flip and try letter C on your own. Letter C, the first part, no GCF, but we can factor into x plus 2 and x plus 2, aka x plus 2 squared. Second part, difference of two squares, x minus 2, x plus 2. So as far as x plus 2 is going to go in common, there's 2 and 1. So least common multiple is x plus 2 squared. X minus 2, 1 and none. So least common multiple is just x minus 2. And that'd be it. So now to actually use this here, example 4, you notice that these are two fractions and the denominators are not the same. So our first step is to actually get the denominators the same by figuring out what can they actually get to. So what is our least common denominator, aka the least common multiple for these denominators? So I'm going to factor out this one on the bottom right here into 3x, x plus 1. And now we might be able to see a little bit better that 3 and 9 can multiply to 9. X and x squared can multiply to x squared. And x plus 1 and nothing can multiply to x plus 1. And I should note it's technically not nothing, it's technically times 1 there. Because otherwise nothing, 0 could not multiply up to that, but 1 can. So our least common denominator is going to be 9x squared times the quantity of x plus 1. So now we need to get both fractions at that point. So the fraction on the left, we're going to multiply by x plus 1 because that's the part it's missing. It already has the 9x squared, but it's missing the x plus 1. So you're going to multiply the top and the bottom by x plus 1 because then you're technically multiplying it by quote unquote 1. And that would end up getting us, as we distribute the 7, 7x plus 7. And the bottom would be 9x squared times x plus 1, which would benefit us more just to leave them factored out like we did in the previous section. On the top right, or the right fraction, it already has the x plus 1 and a 3x, but it's missing another 3x to get it to 9x squared. So then you would add x times 3x on the top is 3x squared, and the bottom would end up being that 9x squared times x plus 1. Now we can actually combine these. So on the top you get 3x squared plus 7x plus 7, and the bottom 9x squared times x plus 1. They just share the same denominator. And you cannot factor out the top, so this is a perfectly fine answer. If you wanted to distribute this 9x squared, you're welcome to. I do not, just for the same reasons as the last section of where we just don't need to. So once again, a good first step is to figure out what the least common multiple is going to be, getting that least common multiple, and then combining, and looking to simplify if you can. All right, moving on to example 4b. Here we have subtraction, so I'm just going to go ahead and change that to addition and change the signs that follow in the numerator, because then that changes the sign of the fraction in general. It's like you multiply the fraction by -1. So these come multiple. Well, let's first factor. I'm going to factor 2 out, get x minus 1 inside. I'm going to factor this into x minus 3 and x minus 1. So these common factors are going to consist of the 2, as well as x minus 3, which this one has and this one doesn't, and x minus 1, which they both have. So now in order to get both fractions at this point, the fraction on the left needs to multiply it by x minus 3, because that's the part that's missing. And I'm not going to, I am going to distribute that x minus 3 in and FOIL here. And the reason why is because I'm going to have to combine anyway. And so I want this multiplied all the way out, so that way I can combine every single term with the appropriate terms or like terms of the other fraction. And we'll see this more in a moment as to the why I'm doing this. So as we distribute that, we get x squared. And I'll show my math off to the side actually to save work. So off to the side, I'm going to show x minus 3 being multiplied with x plus 2. And gets x times x is x squared, 2x, negative 3x, negative 1. And that ends up simplifying to x squared minus x minus 1. So I'm just going to write that simplified version over here over my denominator, my least common denominator. Then the other fraction will come in, and this second fraction is just missing the 2, so multiply the top and bottom by 2. And distributing that in is not bad at all. So we just end up getting 4x plus 2 over that common denominator, 2x minus 3 times x minus 1. So now we combine like terms, and this is a lot easier to combine this than it would have been to combine this with 4x plus 2. That's why we multiplied together. So as we combine these, x squared comes first, negative x and 4x gives us 3x, negative 1 and 2 gives us 1. So I end up getting 2 parentheses x minus 3, x minus 1. Oh, I need to apologize, that's not minus 1 there. I added, for some reason, negative 3 and positive 2 there, where what I should have done was multiply and got positive 6, and that would affect this and that. So my apologies on that. And so I need to change that here. It's only going to be plus 1. I'd rather do 6 plus 2, which is 8. So now we look and say, okay, can we simplify this fraction at all? Can we factor the top and divide anything out? And we can factor the top. The top factors into x plus oh my goodness, I made another mistake. I'm so sorry about that. 2 mistakes on this one. So I corrected it to a 6, but I corrected it to a positive 6. The error should be that's a negative 6. And the reason why, let me zoom in here, is negative 3 times positive 2 would give us not a positive 6, but a negative. So I need to go back through and record that error and fix that. The snowball that became, or came from that. So instead of being plus 6 there, it's minus 6. And instead of 6 plus 2 being 8, negative 6 plus 2 is negative 4. And the reason why that's important is now that it actually factors out as well as correct compared to before. So x squared plus 3x minus 4 is, or factors into x minus 1 and x plus 4. And the x minus 1's reduce to 1 and 1. So here's the x plus 4 on the top and 2 times x minus 3 on the bottom, which once again you could distribute in the 2, just do not need to. Now, if we had not, and once again I apologize for mistakes, if we had not multiplied the x minus 3 and x plus 2 together originally, we would not have been able to combine these two fractions well, or really at all. And then we wouldn't have been able to factor it, and then we wouldn't have been able to reduce it to what we ended up reducing it to. All right, C, I would encourage you to try this one on your own. So I'm going to turn this into addition and change the 6 to a negative. And I'm going to factor out my each part of the fraction that I can. Bottom left, x plus 2 and x plus 2. Bottom right, x plus 2 and x minus 2. So our least common denominator is going to be x minus 2, because there's one of them, and x plus 2 squared, because there's two of them. Fraction on the left has both x plus 2's, but is missing the x minus 2. And I'm going to multiply that out here off the side. I'm going to show that. I'm going to try not to make an error this time. All right, the math should be correct. Emphasis on should be. End up getting x squared minus x minus 2 over my new denominator, x minus 2 and x plus 2 being squared. Then the fraction on the right, we have the x plus 2 and the x minus 2, but it's missing the second x plus 2. So there I just distribute the negative 6 in and get negative 6x minus 12 over my common denominator. Now I combine like terms as I combine these denominators since they have common denominators. So my denominator is the same. The numerators combine into x squared minus 7x minus 14. You might, it's always good to check to see if it's factors so we can simplify anymore, but the numerator does not factor, it is in fact prime. So we're done. All right, moving on to example 5. Complex fractions. So this is what I often call double-decker fractions. There's a fraction on the top and the bottom. Now this is really complex here because we have to combine like terms on combine on the bottom of a fraction two other fractions. So good hint, always simplify the top and the bottom individually first. So what I mean by that is I'm going to quite literally write this where I'm going to write the first fraction in a parenthesis. I'm just going to put a division symbol and then put this entire second fraction in there as is. And what I'm going to do now from here is I'm going to worry about simplifying, aka combining these two fractions. Then when I'm done combining those two fractions completely, like we did in the previous problems, I am then going to worry about taking care of actually the division of these fractions, which would end up multiplying by the reciprocal. But I have to worry about this addition first in that parenthesis. So my least common multiple of this bottom fraction, and maybe you benefit from writing out to the side. If so, write down your least common denominator. And that'd be x and x plus 4. So I have to get the first fraction to that. So I'm going to have to multiply the top and bottom by x. And so as I write this again over here, I'm going to write my first parenthesis as is, division symbol, second parenthesis, x is on the top, and x times x plus 4 on the bottom. the right fraction, 2 over x, I'm going to have to multiply by x plus 4. Distributing in the 2, getting 2x plus 8 over x parentheses x plus 4. So now I'm going to continue combining those. First parentheses stay the same. Division symbol. And combining these to get 3x plus 8 over x parentheses x plus 4. Oh, it looks like I forgot to finish a parenthesis. Now, 3x plus 8 doesn't factor. So now I'm going to treat this just as if it was a problem I saw last class in section 10.2, where my first parentheses stay the same. I'm going to change the division to multiplication, and I'm going to reciprocate my second fraction. And now I'm very thankful I didn't multiply this x and x plus 4 together, because I see, oh, it can reduce with the other x plus 4. Nothing else reduces, so we get 5x on top and 3x plus 8 on the bottom. So after all of what we started with, of this big fraction, it ends up just being this, which to me is very satisfying to see it eventually simplify down and condense to that. Walking back through the steps real quick. So I first wrote it as two separate fractions, the top in parentheses, bottom in parentheses, but I did not flip anything yet because I had to take care of combining those fractions first. And in order to combine those fractions, I had to first get common denominators. So I figured out what my least common denominator was. I then got my least common denominators by multiplying. I then combined the fractions once they did have common denominators. Then once they were combined, here in the orange step, I was then ready to turn this fraction divided by another fraction into a fraction multiplied by their reciprocal. That would be right here where you see the fractions multiplied by their reciprocal. And I cross simplify, and vertically simplify if we could, but we couldn't. And just combine from there. Example 6. Once again, separate these in the two parentheses. First parenthesis being the first fraction, divided by the second parenthesis being the bottom. And once again, you might benefit from writing out the least common denominator. In this case, it would be x minus 3 times x plus 5. So now in order to get that least common denominator, I'm going to multiply the fraction on the left of the second parenthesis by x plus 5, and the fraction on the right by x minus 3. So as I rewrite this, my first parenthesis staying the same. Division. My top I'm distributing to get 2x plus 10. The bottom is staying the same here. And distributing the 1 in the x plus minus 3 to just get, well, x minus 3. Now, at this step, or instead of this step, you might want to write it a different way. You might benefit from writing just this portion like this. What this does is it puts both numerators over the same denominator, separated by that plus sign. If you want to do that, you're more than welcome to. It makes it so you have to write a little bit less, because you don't have to write the denominator twice. So that's completely up to you. That's how I prefer doing it. Once again, that is completely up to you if you want to do it that way or not. If that confuses you, ignore it. All right, so now from there, I'm going to combine these. So my first parenthesis I still need. And the second parenthesis is going to combine into 3x plus 7 over x plus 5, and x minus 3. So now that that second parenthesis is completely, or as simplified as possible, because I can't factor out the top there, I'm going to multiply by the reciprocal now. So first fraction stay the same, change the multiplication, and reciprocate the other one, the second one. So now we look for anything that we can reduce, and I see, oh, I can reduce a few things. So I'm going to reduce x plus 5s and nothing else. So I said a few things, but it's just one. So on the top, you get 3 parentheses x minus 3, which you can distribute in, but you don't have to. On the bottom, you get 3x plus 7. And that would be our answer. I'd encourage you to try example 7 on your own, but that's up to you. So example 7 here, our last example of the day, I'm going to follow this one the same way, where I'm going to write the top in one parenthesis and the bottom in another, separated by a division symbol. Now this one's unique because we have to get common denominators and add fractions in both the numerator and the denominator in the first parenthesis and the left and the right, and the second parenthesis. So my common denominator for the numerator is 5. The common denominator for the denominator is x. So for the first parenthesis, I'm going to multiply the right fraction, which would be 4 over 1, by 5 on the top and the bottom. And that would result in x over 5 plus 20 over 5. The second parenthesis, I'm going to multiply the first, the 8, which is 8 over 1, by x, and get 8x over x plus 1 over x. So now combining each of those separately, getting 20 plus, or x plus 20, I want to put it in standard form with the x first, divided by 8x plus 1 over x. From there, we can say, okay, now it's time to multiply by the reciprocal. So the first one stays the same, second one flips, and unfortunately here, nothing simplifies. So it's up to you how you want to write this. So some people might prefer, once again, multiplying the 8 in, or the x in, and multiplying the 5 in. And some people prefer it separate. So it might look like this for you if you multiply the x in and you multiply the 5 in. Or it might look like this to you. And one of these is no more right than the other. Okay, and I want to note that this is an 8. So those are both perfectly fine answers. That is it today for section 3 of Unit 10.